All right, let's jump right in and talk about machine learning. We're going to break down what it is, how it actually works, and really get into why it's become one of the most important pieces of technology pretty much everywhere you look.
So let's start with the problem we've all dealt with, spam email. Now, how do you teach a computer to catch it? You can't just write a rule that says block emails with the word offer, right? Because spammers will just start writing offer with a zero. The target is always moving. So how do you build a system that can actually keep up? The old school way of programming would have been to create this huge, complicated list of rules. But like we just said, that's a losing battle. It's fragile, and you'd have to update it constantly. Turns out there's a much, much better way. And this slide just nails the difference. On the left, you've got the old approach, this painful manual cycle where a human has to study the problem, write the rules, check for errors, and do it all over again. But on the right, that's the machine learning way. We flip the whole process on its head. We just feed the machine tons of data, examples of spam and not spam, and we let the algorithm figure out the rules for itself. And this isn't just for blocking junk mail. Think about something way more complex, like speech recognition. How could you possibly write rules for every single accent, every pitch, every bit of background noise? You just can't. It's the kind of problem that's basically impossible without a system that can learn from examples.
So that brings us to the million-dollar question, right? We keep using this word learning, but what does it actually mean when we say a machine learns? Let's get a really clear definition.
This idea has been around for a long time. Arthur Samuel gave us this classic definition way back in 1959. And the key phrase, the part that matters most, is without being explicitly programmed. The intelligence isn't coming from a giant list of instructions. It's emerging from the data itself. Now, fast forward a few decades, and Tom Mitchell gives us this more modern, more engineering-focused definition. And this is something we can actually use to build things. It gives us three key ingredients: a task, a performance measure, and experience. Okay, so let's make that totally concrete with our spam filter example. The task, or T, is simple. Flag new emails as either spam or not spam. The experience, E, is all the training data we give it. Thousands of emails that have already been labeled. And finally, the performance measure, P, is how we grade it. It could be something like accuracy. What percentage of emails did it get right? So the system is learning if its performance gets better as it gets more experience. Simple as that. Okay, now here's where the real magic comes in. A system that can only spot spam it's already seen before isn't very useful. The whole point is for it to take what it's learned and apply it to brand new emails it's never encountered. And this ability is called generalization. So how in the world does a machine do that? How does it make smart guesses about things it's never seen? Well, it's not about just memorizing the old stuff. It's about actually understanding the patterns behind the old stuff. Generally speaking, there are two main ways machines do this. The first is called instance-based learning. You can think of this like a spam filter that sees a new email and says, this looks really, really similar to these other 50 spam emails I've seen before. It just finds the closest match in its memory. The second way is model-based learning. This is more like building a general theory. The system looks at all the examples to create a model of what spam tends to look like. And here's a perfect way to visualize that model-based learning. Imagine all those blue dots are our data points. The goal isn't just to connect the dots. The goal is to find that red line, the model that best captures the overall trend. Because once you have that line, you can use it to predict where the next dot is probably going to show up. So how does this all fit together in an actual project? It might seem like some kind of wizardry from the outside, but really there's a pretty clear, logical process behind it all. So a typical project usually follows these steps. First, everything starts with the data. You have to get it and understand it. Then you select a model, kind of like choosing that trend line we just saw. After that comes the training phase. This is where the learning actually happens. And finally, you take that trained model and use it to make predictions on new stuff. That last step is called inference. See? It's a clear, repeatable workflow. But what's really fascinating is that sometimes the learning isn't just a one-way street. After the model is trained, we can actually look inside it and see what it learned. Our spam filter might have found some really weird combination of words that we never would have thought of. This process is often called data mining, and it can help us humans discover patterns we didn't even know were there. Okay, so why does all this matter to you? Well, because whether you notice it or not, this technology is already running in the background, shaping your digital world in some really profound ways. I mean, it is the invisible engine behind so much of what we think of as modern tech. It's what's ranking your Google search results, it's what powers the voice assistant on your phone, it's what recommends that next YouTube video. It has quietly become absolutely essential to our everyday lives. So, if you only remember one thing, it should be this: machine learning is a fundamental change in how we tell computers what to do. Instead of writing out every single step, we build systems that can figure out the steps for themselves, just by learning from data. It's a really simple idea, but with incredibly powerful results. And that kind of leaves us with one last big thought. This new ability for machines to learn from experience, it opens up a whole new universe of problems we can solve. So the only question left is, what should we point them at next? Thanks for tuning in.